Hey everybody, I am Mr. Kilgore and you are in the Intro to Engineering lab. Right now you're going to be looking at computers. This is where we design the products before we build and test them. And so one thing I want you to remember about engineering is that that's exactly what it is. We design, build, and test. And so in this computer lab, that is the design portion. You're going to see some students doing that in just a minute, or they might be around you right now. I want to start by showing you the first project you would do as a freshman, and that is this piston and crankshaft assembly. This is something that you would do and take home. First you have to draw it on the computer, and then you're going to go to the shop and build it, and then there's a couple tests that you would do after that. All right, so I think now we'll come over here right now, and I want to show you the product you're going to do second semester or second quarter, and that is a fling machine. Probably when you go out to the shop right now, you're going to see some students shooting ping pong balls when you leave this room in just a minute. And they each had to design their own, they had to draw each part, they had to assemble it, and then they're doing 3 different tests in the shop right now as you go out there, and dealing with precision and accuracy. All right. So let me just move on. We've got a couple more. There's a fling machine up here. Another project that we do in the intro class is a CO2 car. They also have to design that. All right, on the computer, and then they go out and build it. We race these. We find out the feet per second, the miles per hour. We put it in a wind tunnel to find out the drag applied to the car. We do an alignment test. So it's not just racing and painting. There's quite a few tests that go on with it. And again, they each design their own car. All right. If we look right over here, you can pan that camera over there. We've got some young ladies. They're actually doing right here. Those are the parts for the piston right here. And you can see they're working on that. And they're going to assemble those parts so they can then go build that. All right, good to see. We're gonna go right over here. Here's a couple on the top shelf. We have wind turbines. That's a project that you will do in the intro class. We talk about alternative energy, and you design and build your own wind turbine, and then you hook those together with 3 other wind turbines in your group, and you create a wind farm. You test the amount of voltage output that you have with a digital voltmeter, and try to create the wind farm that produces the most voltage output. So that's like a 3rd or 4th quarter project in the freshman class. And then we've got, this is a water turbine. This would be for the 2nd year class. I'm gonna go right over here and show you a couple other things. Here's a water turbine that we do in the 2nd year class. Hydraulic arm, which I should show you, but I can't get it down. A couple more CO2 cars. This is what my sophomores are doing right now, is they're building trusses and bridges. And if you go out to the shop here in a minute, you'll see a hydraulic press. We actually load those up, and some of these trusses will hold as much as 500 pounds. This happens to be a bridge, so we do some of that. We have some VEX materials right here. A lot of our assignments in the 2nd year class, we build the structure out of a VEX material, which is what you see here. These are actually, these are gonna stay in robot form. And in my 2nd year class, the sophomore class, they are currently working on programming these robots that you see right here. Okay. And then I think we got a couple more guys over here working on Autodesk Inventor, which is our main software program that we use. You can kind of see that these guys are actually working on an inventor certification. So that means if they're coming here after school and they're working on this so that they can have a certification in Autodesk Inventor, like a certificate that will stay with them wherever they go. That looks better on an application or a resume, anything like that. Okay, I do have one more thing I want to show you here. This is a project from the second year class. We study velocity and trajectory. So those students in the shop actually make a projectile. They turn it on the lathe and it goes in here. We push the projectile down in here like this. We pump it up with this air canister. We pump it up, and then when we turn the valve, that projectile is going to shoot out. And some of them we do this out in the parking lot, and some of these go about 200 or 300 feet. If we know the angle that they're shot at and the distance, then we can find the velocity, the muzzle velocity of that. So I'm really into that kind of stuff, and this is a great spring project that we do. So just before you are done here and head out to the shop where I probably am, I just want to say that if you're in the engineering department, you can be involved in a student organization called Skills USA. Our school has several student organizations. We have HOSA, BPA, FCCLA, FFA, and these students here are in Skills USA, and we have a competition just like everybody else. Even if you're not going to do Skills USA, you should do a student organization because it looks really good on a resume or an application. You're probably not going to have a lot of job experience. A student organization gives you that type of job experience. So I would encourage you to do that, whatever pathway you choose. All right, well, thanks for listening, and you can head on out to the shop now, and right through that door there, and I'll meet you out there.